Supernova-style science news with Julie 7 Sage.
Antimatter is a big thing in the sci-fi industry. They showed us something that can create chaos or energy, that antimatter devices exist. But in the real world, there is antimatter that scientists have made, and scientists have just for the first time viewed a light spectrum of an antihydrogen atom. But first, what is antimatter? Antimatter are particles of the same size and mass, but with the opposite sign. So protons, which have a positive charge, its antimatter would be antiprotons, which have a negative charge. And electrons, which have a negative charge, the antimatter would be positrons, which have a positive charge. This is a hydrogen atom, and this is an antihydrogen atom. The reason why we know it's antimatter is that whenever it comes in contact with regular matter, they annihilate each other. This is one reason it is difficult to study antimatter, to compare the differences between antimatter and regular matter for things like gravity or light spectrums. Why would we want to look at the light spectrum? A light spectrum gives you a fingerprint of an element. The way a spectrum is a fingerprint is each element emits specific lines of color in the spectrum, or rainbow. So when looking at the spectrum of a substance, you know what elements are in it, or if it's just a single element, based on which lines show up in regular matter. Like, this is hydrogen. This is oxygen. See the difference? But this isn't the full view. This is the optical spectrum. There is also an ultraviolet, infrared, etc. The scientists at CERN used a laser with specific band in ultraviolet, a very specific color, to look at the ultraviolet section of the hydrogen spectrum, called the Lyman series. This is what it looks like. The researchers wanted to see if they had the same alpha spectrum line, a very specific hydrogen line called the Lyman alpha. The Lyman alpha line is when the electron moves from the first to the second shell. CERN has obtained the Lyman spectrum of antihydrogen to see if there is a difference. Here's what they found. For this line, there is not much of a difference. But this is still exciting news. 1, it shows how antimatter and regular matter is alike. 2, there are still more lines that hydrogen emits that they haven't tested in antihydrogen. It all depends on the sensitivity of the equipment, and with more sensitive equipment, they may be able to find the other lines of the spectrum. So there may be some difference, but it is very, very small. If you'd like to find out more, go to the link below in the description. You can find out more about this experiment and others done at CERN. Please subscribe, watch some more videos, share some science, and show your supernova style.